So this is the video for Project 1 in Fidel's class, and we were tasked with a very open-ended project. And the task was to develop a real-time visual inspection for an additive project, or an additive process, or 3D printing, we call it, to show you what we've done, what we've learned, how we've applied some of these things we've learned in class to this actual project. You're going to see interviews and images and video of the actual process of it happening in real time.
Additive manufacturing is when you make a product layer by layer. Traditionally, we've made products with mills or lathes or subtractive methods where you cut away from the part.
So specifically, we were asked to monitor defects while making the product, so you wouldn't be wasting all your material time and at the end money making something that already has a defect in it.
Being able to do an inspection process and say these many parts are going to be defective or they're not going to meet the standard that we need, and stopping it is going to help reduce excess waste and cost by using up material.
So just tell me, what are some of the problems we have with 3D printers?
So the one that we're looking at is warping, which is when the corner of a part starts raising off the platform before it's even finished printing. And then other ones that we've seen are with problems with resolution. So depending on how dense of a product you're trying to make, there can be gaps in the product that make it so it's not the ideal flush, flat surface.
I think where we're really going to come in is in the process planning part, because there is no process planning. So there's actually we're going to be integral in trying to make this a mass production product or process. Whereas right now it's more for prototyping and for small batches and individual outputs.
We're painting a picture, and what's the goal in mind here, and how is MATLAB going to help us do that?
Okay, so the first thing that MATLAB does is it allows us to interface with the camera. It's kind of like MATLAB has this eye, which is the camera, which is looking at what we're printing. And we're able to capture images in real time and then have documented how all the pictures through the progress of making the part. The first pictures that we capture should have show a flat part. And so at the time, when we start taking a picture of the part and comparing it to the first pictures, if we start seeing that the part is moving up, as in looking at the pixels specifically, then we should be able to tell this is occurring, and MATLAB could send a notification through our code saying, okay, warping is occurring now, so we need to stop this, or we need to make adjustments to the printing process to prevent it from happening again.
Let's kind of attack each of these issues either independently or together to have a solution.
So one thing that we found very interesting was that our group came up with the idea that if these parts are bending, there's got to be what's behind it. What's the reason behind this bending? And we determined that, well, as things cool, they condense and they mold, and so almost like a Prince Rupert drop. When something cools, it condenses, and if it's heated, it'll still be moving around, and it can move and shift because of that condensing. So one thing we thought about, well, what if there's a way we could detect heat? And so we went ahead and looked at a FLIR camera, and we put a FLIR camera in front of it, and that did actually provide evidence that, yeah, that this is why this stuff is happening. And we found later in other projects and other further research that people were using infrared cameras to actually detect and find this stuff, but they had $50,000 cameras with high resolutions, and we don't have that budget. But it was very interesting to find that we, as students, were attacking this and approaching this the same way any other engineer in the world with a higher budget would approach the project, which we thought it was extremely neat. But what we really lacked was a camera with high enough resolution to really make this a valuable thing for our project.
how we're going to let someone know that there is a defect.
Well, one of the possibilities in our project is sending a text message to perhaps a supervisor or the machine operator or something like that when we detect defects, or MATLAB code would send a text message to them, and so they would know to alter the machine or scrap the part entirely or just adjust the part somehow.
So this is a paper that we found to be particularly pertinent to what we were doing. They're essentially doing the exact same thing that we're attempting in here, only they're using a lot more expensive equipment. So they're trying to test for how much temperature affects warping within a part. They actually monitor the temperature of the entire oven. We're going to have a nice table of contents, just a classic layout for a technical paper with an intro and then method, results, conclusion, that kind of thing. So we have our safety assessment.
Okay, so we are going to test the text message alerts right now. So we're running our GUI, and the first thing we have to do is add the contact information. So we're just going to use my cell phone. Don't get any ideas. We're going to say alert and have it say error. And provider is Verizon. Alright, so we're going to start our capture and select our region of interest. Alright, so there's no error right now because the image is not moving or changing. So when Amanda moves this out of the way, it's going to detect an error, and it should come through to my phone.
Soon. There it is.
Alert, error.
Also, you can stop the capture now if you want. Here we are just setting up the MakerBot and opening up the software that interfaces with the MakerBot, and so we're loading a part, and so this is the part we're going to be printing, and it's selected to print on the left extruder because that's a bright orange color, so it'll be easier to detect than the darker blue color that's on the right extruder. And we've messed with it and scaled it so that it's shorter, so it should take a shorter time to print, but it's much bigger, so those will kind of offset each other. And so just want to make sure we have the right device, which is the Replicator 2X. And then go to our settings and make sure that we have the desired settings, which we selected a lower resolution so it will print a little bit faster. We have a 10% infill, which also should help with the printing speed. And then the temperature is set for the left extruder to be slightly higher and the build plate to be much lower, just to see that the curling effect occurs away from the plate. So we'll just, and also we have the right material selected. So we'll just save these settings. And then once you make sure everything is set up right, you go up to the print button, let load, and then this, oh my gosh, it's gonna take 31 minutes to print. I might have to mess with this a little bit more, but you can either increase or decrease the print time based on what you want to print. When you're ready to print, you just say start print and it will start the MakerBot.
Okay, so expected build time is where you put how long you think it's going to take for the part to print. So that just gives you an idea of how long you have to run the camera and capture data. And then seconds between frames, that is the number of seconds or how often MATLAB is going to examine the part. So instead of like continuously every single second having to run it, if you can put more of a spacing between captures, you can process it at that rate. So right now it's going to be 4 pictures per minute. Okay, so we also have the setup contact. you can enter a phone number in here, and then you can also have what you want the title of the message to be and the body of the message, and then you select the provider, and that will send a text message if there's a problem.
The region, we're cropping it to get a better view, and then setting the actual region we're interested in inspecting. And then now it should be detecting errors as the part builds, which will display in the command window.
So talk about the time between errors again and point on MATLAB where it is. So
Okay, so we are capturing every 15 seconds. So here's where it's telling us there was no error this time. So it took 15 seconds for this one to come up, and now 15 seconds later it's going to come up with the next one.
So every 15
next
seconds.
picture.
Yeah, so every
Yeah.
15 seconds we're capturing a frame, and we're taking that frame and comparing it to the first picture where we had set the initial picture, where, you know, it brought up that first window where you cropped it and then select a region. That's the initial picture. It's comparing all the rest of the pictures.
All right, go ahead and explain the use historical data.
Okay, so when this is selected, it changes from doing a live feed. So if we wanted to demonstrate this to somebody and we weren't in front of a printer, we could access previously recorded data and be able to analyze the previously recorded or previously captured images.
So you're going to try to get that back corner too?
I mean,
That's fine. I mean, it's like I said, it's only going to capture...
These are the two corners you want.
Yeah,
right?
but it's only going to capture if there's black where there should be white. It won't matter if there's white where there should be black.
so this should be just fine.
Yeah, that should be fine. Yeah, it's not going to matter if it has black and turns white.
I mean, it's
only...
already peeling, so.
You should stop. Oh,
Oh, it detected the error. No, it detected the error.
It still detected the error though.
See, it's saying detect error right there.
Which is interesting. Of course, it is peeling very quickly.
It is peeling, that's why it's detecting it. Very nice.
So,
We're about to get the text message.
oh, you referred to the text message
No,
too?
I did do the text message.
Okay. Oh, you got it too.
There it is.
Woo!
So there's like a 5 or 10 second delay for the text message, but that's just because.
Yeah, it's a couple seconds, just because it has to run the code, and the code has to output. So this really actually peeled really
But
quickly.
it worked.
Yeah, that's true. It worked on the second.
I wish I could freaking focus this.
So it might have taken a little bit longer to go if we had had a lower error number detection. I
There's
might
the
stop it
text message.
because we had this happen before and it ran into it.
And there is the defect.
Oh, you can stop capture by the way. I was gonna go to 60, but. And see, that's something where we might want to do, okay, if it has more than 3 errors in a row, or, yeah, we might want to try to build that in there. So it only detects after so many errors occur. See, now it should be detecting an error now because it's peeled. Like you can see it moving.
So when it detects one error, it will send a message to your phone, right?
Yeah, it
Yeah,
detects.
it
Right
already
now,
did
it's set up to detect the first error that occurs and send a message. And that's
When
going
it's right
over.
there?
Yeah,
Yeah.
and it might affect it. I'm not sure.
So yeah, now it's pretty consistent with the errors.
Yeah, and that's something
As
that
you
you
can
may
see.
want to. We might want to build into the code a little bit more.
It could be that we could just make our, you know how, because we're controlling how it reports the errors 2 ways. Firstly, how many pixels is appropriate for it to be an error?
Yeah.
And secondly, how many errors in a row does it have to report? So maybe we could make it harder on this part.
That's
but
what I was
easier, but
So this project was a big challenge for us. But luckily for us, we're at Auburn, and our professors over the years have taught us some things and how to do and how to approach problems. With the different types of personalities, we were able to come together and produce something that solve a problem, a very real world problem. This project taught us a lot.
I found 11 information about third party third party analyst who did the inspection process for like traditional subtractive manufacturing process. And so I don't like this stuff.